Unit 1 focuses on the imaginary number system. What's important for us to remember about the imaginary number system is the number I. And there are certain facts about I that we need to recall. First of all, we need to know that I is always equal to the square root of -1. And this is the base of the number system. If we don't recall this fact, then we're going to struggle throughout our use of the imaginary number system. Now, based off of that fact, we can get several powers of I going, which will allow us to notice a pattern here. If I think about I squared, I know by definition I squared is the same thing as I times I. We just defined I to be equal to the square root of -1. So I can think about this as the square root of -1 times the square root of -1. Which then is the square root of -1 times -1. And we should know at this point in our lives that when there's a square root, I'm looking for pairs underneath that root that could come outside. So when there's a pair of -1s, those can come in front of my radical because they're a pair of numbers, and that's what square root's always telling me to look for. So therefore, I know that I squared is always equal to -1, and that's a quick algebraic proof of that. Now, if we keep exploring this pattern, and we move on to I to the third, we think about I to the third as I to the second times I to the first. We use the definitions that we've already derived, which would give me -1 times I. And I is equal to the square root of -1, but we're just going to leave it as our base I because that's the base of the imaginary number system. It's okay for me to leave I, which gives me -I. Therefore, I to the third can always be equal to -I, and we'll always replace it as such. And now I to the fourth. The easiest way, we could break this down several ways, but I'm going to choose to break it down into I squared times I squared because I squared is equal to a real number, and that's what I'm used to operating with. So I know I to the fourth is equal to I squared times I squared by definition of exponents. So I know I squared is equal to -1. So this is the same thing as me saying -1 times -1. These are real numbers that you've always operated with. So I to the fourth is therefore equal to +1. Now, it's very important for me to remember these facts. I'll always leave I as I. I'll always replace I squared with -1. I'll always replace I to the third with -I. And I'll always replace I to the fourth with 1. If I were to keep exploring here, I would go I to the fifth with my powers. I'm going to notice a pattern that's just going to keep repeating. I can break down I to the fifth to be I to the fourth times 1. Times I to the first, which would give me 1 times I. Which is I. I to the sixth, I could think about as I to the second times I to the fourth, which would give me -1 times 1, which gives me -1. And I'm noticing that those four answers, I, -1, -I, and I, are constantly repeating. So these four are really all I need to remember. I is equal to I to the second is equal to -1, I to the third is equal to -I, and I to the fourth is equal to +1. This is the base of the imaginary number system.